Hello students, today we will be solving question number 3 and question number 4 from the same paper, CAT 2018 paper from the slot 2. So let's start off with the question. The question that we are going to solve is that Ramesh and Ganesh can together complete a work in 16 days. Now after 7 days of working together, Ramesh got sick and his efficiency fell by 30%. As a result, they completed the work in 17 days instead of 16 days. Now, if Ganesh had worked alone after Ramesh got sick, then how many days would he have completed the remaining work? The options that are given are 14.5, 11, 13.5 and 12. So this is the question that has been given to us. So it has been said that Ramesh and Ganesh can complete a work in 16 days. So they worked for 7 days together and thereafter Ramesh got sick. So what happened because of that? Because he got sick, Ramesh's efficiency fell by 30%. And then they could not complete the work in 16 days, rather the work is completed in 17 days. Now the question that comes up is that if after Ramesh got sick, only Ganesh had worked alone, then in how many days would he have completed the remaining work? Okay, so let us start off with solving this problem. As you can see, there is a lack of space over here. We'll try to incorporate a new page over here. Okay, so we are good to go. So what we'll try to do over here is that let us take that capital R and capital G are the rate of works of Ramesh and Ganesh. Okay, so by rate of work we basically mean the amount of work that Ramesh or Ganesh do in one day. So now it has been said that in 16 days, when Ramesh and Ganesh work together, they complete the work in 16 days. So we can definitely therefore say that R plus G into 16 will be equal to 1. So this is the first equation. So this will give us that 16R plus 16G will be equal to 1, or we can say that R plus G will be equal to 1 by 16. So this is the equation 1. Okay, now it was said that they worked for 7 days and after that Ramesh fell sick. So we can say that for 7 days the amount of work that was done was 7 into R plus G, and this will be equal to 7 by 16, and this is equal to the amount of work done by both Ramesh and Ganesh in 7 days. So the amount of work that was remaining was the amount of work remaining will thereby be equal to total amount is 1 minus 7 by 16, which will be equal to 9 by 16. And now it has been mentioned that after the 7 days when Ramesh fell sick, his efficiency fell by 30%. So we can therefore say that after therefore new efficiencies or new work rates, we can say the new rate of work of Ramesh will thereby be 1 minus 30% of R, or we can say yes, 30% of R. So this will be equal to 0.7 into R. Okay, so therefore now these two Ramesh and Ganesh with the new work rates, they work for 8 days more. So therefore we can say that 0.7 into R plus G, since they worked for 17 days in total and initially they worked for 7 days, so the number of days they worked with the new work rates will be equal to 10. So this entire structure 0.7 R plus G is the amount of work that they do in 1 day, and this is multiplied by 10, and this is equal to the amount of remaining work. So this will be equal to 9 by 16. Okay, so this gives us that 7R plus 10G. 7R plus 10G, I used a small little mistake, but nevertheless the meaning is conveyed to you. 7R plus 10J will be equal to 9 by 16, and this is the equation 2. Okay, so upon now solving it, if we equation 2 minus 7 into equation 1, so this will give us 10g minus 7g will be equal to 9 by 16 minus 7 by 16. So this will be equal to 3g will be equal to 2 by 16, which will be equal to 1 by 8. So therefore g will be equal to 1 by 24, and this similarly gives us that capital R will be equal to 1 by 48. Now the question that we need to find, the answer to the question that we are supposed to find out is that if Ganesh had worked alone after Ramesh fell ill, then how many more days would it have taken? So the amount of work that was remaining was 9 by 16, and it has been already found out that the rate of work of G can do 1 by 24 of the work in one day. So the remaining work could have been done by Ganesh so the number of days required by Ganesh to complete the remaining work working alone would have been equal to the amount of total work remaining, that is 9 by 16, divided by the amount of work that he does in one day, which is 1 by 24. And upon solving, this will give us 9 by 16 into 24. So this would have given us, if you divide both the numerator and the denominator by 8, this will be equal to 3 by 2. So this would have been 9 into 3, 27. 27 by 2 would have been equal to 13.5. So 13.5 extra days would have been taken by Ganesh to complete the remaining work had he worked alone. And 13.5, this is the option which is given by in the question. So 13.5 is the correct answer to the said question. Let's move on to the next question, which is question number 4. Let's start off with question number 4 now. So in question number 4, it has been said that points A, P, Q and B lie on the same line such that P, Q and B are respectively 100 km, 200 km and 300 km away from A. So now cars 1 and 2 leave A at the same time and move towards B. Simultaneously, car 3 leaves B and moves towards A. Now car 3 meets car 1 at Q and car 2 at P. Now if each car is moving in uniform speed, then we need to find out the ratio of the speed of car 2 to that of car 1. So now here it has been mentioned that point A, P, Q and B lie on the same line, and P, Q, B are such that P is 100 km away from A, Q is 200 km away from A, and B is 300 km away from B. Now what happens is that at the same time, cars 1 and 2, they start from point A and start moving towards point B, and car 3 at that same time, it leaves point B and starts moving towards point A. So what happens, these 3 cars, they meet each other one after one another. So what happens, the car 3 meets car 1 at the point Q, and car 3 meets car 2 at the point P. So now if this is the case, in that case we need to find out the ratio of the speed of car 2 to that of car 1. So this is what we are supposed to find out. The options that have been given are 2:7, 2:9, 1:4 and 1:2. So these are options that have been given. For solving this question, let us incorporate a new blank page over here. So before we start solving this question, what we'll try to do, we'll try to incorporate a diagrammatic representation of the scenario over here. So here it has been given that there are 2 points. If this is the straight line, so we have A and B over here, and then we have 2 points P, and then we have another point Q over here, and this is the point B. So the distance between the point A and P is basically 100 kilometers. The distance between the point A and Q is 200 kilometers, and that the distance between the point A and B is 300 kilometers. Okay, so as you can see, all the points are equidistant from the adjacent point. So the distance AP is equal to 100. The distance PQ will be 200 minus 100, it will be again 100, and QB will be 300 minus 200, so the distance QB is also 100. So now it has been said that car 1 and car 2, they both start from point A and move towards point B, and at the same time car 3, it starts from the point B and starts moving to the point A. So now the question that has been given is that the both cars 1 and car 3, the car 1 and car 3, they meet at point Q, and at a point P, car 2 and car 3, they meet. Okay, so this is the scenario over here. In that case, we need to find out the ratio of the speed between car 1 and car 2. So what we'll try to do is that when car 1, or we can say car 1 and car 3, when they meet at the point Q, let the time taken be t1. After time t1, they both meet at the point Q, and after time t2, car 2 and car 3 will meet. So this is the assumption that we have made over here. So now we know the speed is equal to distance by time. So what we'll try to do is that the speed of car 1 will be equal to the distance traveled by car 1 divided by the time taken. So distance traveled by the car 1 will be basically, since they meet at the point Q, will be 200 kilometer divided by t1. And similarly, the speed of the car 3 at this very instant will be equal to the distance traveled, which will be equal to QB. QB is equal to 100 divided by t1. So this implies that t1 will be equal to 200 by s1, and this will be equal to 100 by s3. So after proper cancellation, this comes down to s1 will be equal to twice of s3. This is the first condition. Let us move on to the second condition. The second condition is that car 2 and car 3 meet at the point P. So if t2 is the time taken for travel, in that case we can say that the speed of the car 2 will be equal to, since it has only traversed 100 kilometer, so this will be 100 by t2. And in a similar case, the distance traveled, the speed of the car 3 will be equal to, since it has to travel the distance BP, this will be equal to 200 kilometer divided by t2, and this will give us that t2 will be equal to 100 by s2, and this will be equal to 200 by s3. And after proper cancellation, this comes down to s3 will be equal to twice of s2. So this value of s3 will incorporate it over here. So that will imply us that s1 will be equal to 2 into 2 into s2. This will be equal to 4 of s2. And remember that we are supposed to find out the ratio of the speed of car 2 to car 1. So this will be basically equal to s2 by s1, and this will be equal to 1:4. So the ratio that we are looking for is 1:4, and that is given by the option 3 in the question. So the option 3 is the correct answer to this particular question. So in this video, we have today solved question number 3 and question number 4 from the CAT 2018 paper. We'll be solving the next questions in the subsequent videos. Thank you very much.